welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Before we start, I'm excited to share that we're hosting Rustasia Conference 2025 on March 28th in Hong Kong. This is your chance to dive into the world of Rust in Asia and beyond. We've already got Tim McNamara, the author of Rust in Action, as our keynote speaker, and more speakers will be announced soon. We're still open to speaker proposals until December 31st, so get yours in now. Don't miss out. Our early bird ticket deals wrap up by Thanksgiving, November 28th. Check out all the details at www.rustasiaconf.com. Now back to the episode. Today we have Pete LeVasseur. Is that correct?
Yeah, close enough. I can't even say my own last name, so yep, works with me.
We had this discussion about your last name actually at GoSim about 3 weeks ago.
Exactly. I'm an American success story. I don't even know how to say my last name, right? So
It's very American of you. Yeah. It does seem French. So when it comes to French words, we're not that good at it. And we're both from the Louisiana Purchase area, right? So our French is worse for some weird reason.
Yeah, so we're, I think, both Midwesterners, yeah?
Yeah.
Keeping the dream alive.
But Pete, just a quick intro about who you are, then I'll let you go ahead and introduce yourself. So you are a maintainer of Eclipse uProtocol. Now I'm going to hand it over to you to give the real introduction. I want you to go ahead.
Sure, yeah. So my name's Pete LeVasseur. So as Alan said, I work on Eclipse uProtocol. So it's this software-defined vehicle communications framework. It's really something that's supposed to help us be able to reuse software more effectively in vehicle and be able to move software around between different modules and stuff like that. So I've been working in the automotive industry for 10, 11 years now or so, and mostly spent a lot of time doing automated driving, kind of algorithm development, but switched about a year ago, 10 months ago, something like that, over to this more like middleware system software domain. So yeah, happy to be here.
Let's talk a little bit more about you because we sat together at this special dinner at GoSim, and I remember you don't have a very extensive career. It's kind of not that many jobs, right? I think you had 3-4 jobs in your career so far?
Yeah. So so it's a pretty typical career path, I guess, of many people in Metro Detroit, which is start out at like a supplier or two, and then move to an OEM. So when I say these things, it's like starting out at, say, like a Continental or a Denso or a Bosch, and then moving to an automaker like, say, General Motors or, Ford, that kind of thing. Pretty typical kind of career path. So yeah, a couple of years at each of the suppliers, and then around 7 years at GM.
I mean, that's a long time to be at GM. And when you think about cars, you don't really think so much about software, right? So were you surprised that there's software, and what were you actually doing at GM?
So in another life, I would have been like a mainframe software engineer working on assembler, but there was sort of an attempted hostile takeover of the company that I would have joined. So that sort of changed my career trajectory. And so I was, reaching the end of grad school and looked around and said, okay, what is there to do in the Metro Detroit area that's software? And so I found that automated driving was kind of like, this was like 2011, 2012, 2013, Waymo was out there. Things were pretty interesting regarding that. So I joined a research group at Denso that was working on automated driving. So that seemed like a cool area where I could learn a lot and do a lot of software. So that's definitely something that I hadn't thought about prior to then. Yeah, you're right. People usually don't think about software in cars.
That's actually all the more reason to kind of get into uProtocol. I don't want to get quite into that yet. Maybe it's just because when I went to GoSim, we all were talking about automotive because Florian with Ferris Systems and talking about Ferricine was there. You were there. And we had this big discussion about automated driving. Is it called automated driving? Is that right?
Yeah. I mean, automated driving, automated vehicles, autonomous vehicles. Goes by many different names, but even more than that, ADAS, active safety. I know too much jargon from the industry. But it's an interesting domain. There's been a lot of work. It's like the Gartner hype cycle, right? So I think it's kind of hit its peak. And I think we're a bit on the downslope where there's some, I would say, kind of acknowledgement that a lot of these sensors that we have on vehicles are quite expensive to put on them and are not perfect. And there's different modalities that are needed to see through say, fog and these kinds of things. There's a lot that goes into it that I think puts us out a little bit further than many would hope for sort of truly like level 4, level 5 automated driving. But yeah, I could talk your ear off about this kind of stuff for a while since, yeah, it was what I did for a little bit.
Well, actually, if you don't mind, can we talk about the different levels? Because the funny thing is, like, I was trying to listen to the conversation and I kept hearing about levels and I kind of had an idea about what they were, but at the same time, I wasn't exactly sure, right? So there's how many different levels is there and what is each level?
They have a spec, I forget the name of it off the top of my head, but they've got 5 levels of this. They're 1 indexed, not 0 indexed. So anyway, it's 1, 2, 3, 4, 5. So 0 is like no automation, but then it goes all the way up to sort of complete automation within, some sort of domain. So you've got, like level 1 would be something like automated cruise control or lane keeping. So that's where you're controlling sort of one directionality of the vehicle. So you're either controlling lateral or longitudinal control. So you're either, preventing yourself from bumping into the car in front of you or staying within the lane. And then level 2 would be you're controlling 2 modes of actuation. So both lateral and longitudinal control. And there's another component of this that is the sort of where the responsibility lies should there be some sort of accident. So level 1 and level 2, the responsibility is 100% on the operator of the vehicle, so the driver, should there be any kind of accident. And then there's this sort of switch when you go from level 2 to level 3, where it's kind of like the partial responsibility on sort of both sides if there was some sort of accident. And then level 4 is 100% on the automated driving system to sort of keep you safe, but it's in sort of more limited domains. Might be like a certain area or certain operating conditions like clear sunny skies and those sorts of things. And then like level 5 would be, complete perfect automated driving everywhere all the time, works no matter what. And then again, that's 100% responsibility of the automated driving system to keep the occupants safe. So yeah, there's this interesting like kind of, I could talk about this too, but there's this kind of interesting thing that's happening in the automotive industry where everybody wants to say that their automated system is like level 2.9999999, where they want to just sort of keep adding functionality and features, but they don't want to actually take any of the responsibility of, should an accident happen. There are examples. There are automakers that are putting out level 3 systems, but they're typically like low speed, low risk kind of situations.
When we were talking together, I heard from the one guy who said it was that I think is it level 3, it's like people the manufacturer doesn't want to do it because they said that, it's not really clear if it's going to be man or machine and that they'd rather it be like fully automated or non-automated. So that way, like the fault of when something happens is more clear rather than having this kind of murky, like, well, we don't know if, our system made a problem or if it was the driver who would like jerk the wheel or whatever. Is that really the case?
Yeah, exactly. Yeah. So that's a little bit of what I was touching on where, there are some players in this automated driving space that I think like famously the folks at Waymo, I think believe this, that we should just shoot for straight for level 4 because that avoids kind of these in between stages where it's not clear who owns the responsibility if there's an accident, and having the driver in the loop may cause more harm than good. It's an interesting take. I do think that level 3 is a bit of like a murky zone because of that. So yeah, that's a little bit of the reasoning behind that, I think.
But then there's the question of like, I don't know if a fully automated system that you said that's level 4, right? It's like a fully automatic can do all the driving for you. I mean, that sounds kind of scary because machines can make mistakes. I mean, after all, humans can make mistakes, obviously, and humans are writing the code, and even if machines are writing code, like the code that wrote the code that does that is still written by a human eventually. So, like, I guess level 4 is kind of really scary. And then you also kind of brought up some points when we're eating together at another time where, the technology also, I think there's some talk about LiDAR and how I think you said that's actually a good technology to use, right? But then some people don't want to use that. This topic can go on forever, but I just want to touch a little bit more on it because it is kind of interesting.
You're right. I mean, essentially, it's like turtles all the way down, right? Like at the end of the day, there's a human somewhere in this chain that, maybe they're not the driver in the car. Maybe they're not the programmer of the software that's driving the car. Maybe they're like the programmer or a data scientist or something that's way, way, way upstream of that made this tool, which made all this software that goes in the vehicle. But you're right. I mean, there's a human at some point in that chain, and yeah, mistakes can be made. But I think that to kind of separate the points, the point about sort of level 4 automated driving, I mean, there's a pretty clear distinction between, in my mind, what separates like a level 4 automated driving vehicle versus the lower levels. I think a level 4 automated driving vehicle, to your point, should have multiple sensor modalities installed on it. So not only should it have cameras, cameras are great, they're very cheap, and we have a lot of good technology around how to detect things in cameras. And there's really good neural nets these days and things that are very good at getting, say, like even the ranging information from cameras. But at the end of the day, this is not a sensor that can truly sense distance. It's not a time of flight sensor. And so it can have issues if you've got fog. It can have issues if you've got rain. And so that's why it's very typical when designing a sensor suite for an automated driving application to consider, say, radar and LiDAR, because these deliver other benefits, right? So LiDAR, which you mentioned first, this in the automotive setting can really help provide better ranging information. So there are neural nets and things these days, which with a camera, say a single camera, can give you some idea of depth, but you really cannot beat like a laser physically shooting out into the world, hitting something and bouncing back to be received. That is sort of like the gold standard. There are, in automotive applications, it's improving, but there's still a bit of a limitation in how many lines of a LiDAR you can get in an automotive application these days that you would sell to a customer, because typically you have to have those be like solid state. They need to be sort of packaged up well. But on the other hand, if you have like something like a Waymo or some other robotaxi, whatever it might be, those are not in customers' hands, right? Day in and day out. Like these things can go back and get serviced. So those level 4 automated driving vehicles, those can have tons of LiDARs on them. They can have mechanical whirring LiDARs spinning around because they can be fixed and replaced. But in sort of the retail setting, it's not as easy to get such a LiDAR in a sensor package. The other sensor that's very important is radar. So radar is great for dealing with things like environmental conditions, like if you have rain, if you have snow, if you have fog. Radar can actually penetrate these things. So it's still possible, say in like a snowstorm, to be able to detect a vehicle that's in front of you. Whereas with, say, like a camera, this may be very challenging to do just based on the limitations of the sensor. It's very typical when designing an automated driving system that we do want to give great care to how we pick sensors, where we position them on the vehicle, and how we sort of cover the weaknesses of each with the strengths of another.
We're also still kind of discovering, where to put things, right? There was that kind of famous case that you also brought up when we were together about the car that went under a truck, right? Because it didn't have a sensor pointing high enough to kind of see this obstacle, right?
Yeah, it's unfortunate when things like this happen because of sort of not considering these different sensor modalities. So in that case, for example, automotive radar is usually not great at detecting height, not great at detecting sort of your vertical. And so if you have something like that truck that's there and you have only, say, radar and camera, your camera may be malfunctioning at the time, something may not be working correctly. And then the radar may be saying that essentially looks like an overpass. It essentially looks like an overpass that's not really in your way because it can't discriminate between something that's sort of at ground level and something that's higher in the air that you could drive under. And so that's where I think that a lot of care should be put into which sensors we choose and where we position them on the vehicle for automated driving. I think that it's quite irresponsible to not think of these things, before putting that sort of system out into the world.
Yeah, it's a good point. Also, let you kind of think about the world, right? When we experience the world, we don't have just one sense that we experience everything through. We have to kind of combine different things, and then we know what this stuff is, right?
Yeah, I mean, sure. So there's sort of the way of looking at things of saying like, okay, well, I'm a human. I have just like two eyeballs. I have stereo vision essentially, right? I have two cameras mounted here. So I'm able to do depth perception. Sure. That is 100% true. However, we also have other indicators like you're saying. So like we can listen for things, and we also have a lot of built up historical information in our data banks about what's typical in a driving situation, that at least these days, these automated driving systems don't quite have that level of intelligence or built up level of experience to be able to rely on those things. So that's where putting some emphasis on choosing the right sensor loadout, I think, is extremely important. We have a lot of really good algorithms for doing things like path planning. We have a lot of really good algorithms for doing things like detection of things in the environment. But at the end of the day, a lot of the limitations come from sensing.
I kind of want to drift away this topic because I feel like we can stick on this topic for a while.
Please do. I'm stuck.
Well, I want to start getting into more into the project, but I think it would be interesting to hear more about your experience, right? Because when you came to GM, you were not working with uProtocol from the beginning. You were working with something else. So can you kind of talk about your journey till you got to uProtocol?
Sure, yeah. When I was at GM for most of the time, I was working on another automated driving project. So, yeah, I think that this is like out in the open, but it was called Ultra Cruise. So, Ultra Cruise was an automated driving project that they had started to sort of take their existing Super Cruise product and expand its operating domain out to, instead of just the, say, controlled access highways where sort of you have an on ramp and you have an off ramp. So expanding that out to, say, surface streets and subdivisions and really any kind of road. So I spent a lot of my time working on this project at GM, primarily working on algorithms in the localization space. So if we take, say, perception, we take map, and we have to figure out how do we associate these things together? How do we figure out where we are in relation to this map that we're using to drive? That's really a lot of what I did for most of my time at GM, learning things along the way about sort of larger company dynamics and how to interact with many, many more teams. As before joining GM, I had mostly worked on much smaller teams and sort of research and advanced engineering type topics. And it was quite the change up to working as part of like a many 100-person team, like organization, I guess, more like on this localization team. So yeah, that's what I did for most of my time there.
But at what point did you start to get into the uProtocol?
So uProtocol, yeah, so about a year ago, GM decided to put down Ultra Cruise. So decided to basically park this project, and instead of going for kind of like a revolution in this space, going more for like an evolution in this space. So deciding to instead build upon their Super Cruise product. So this was unfortunate, in my opinion, and made me do a lot of soul searching on, okay, this thing that I've worked on for 6 years or so, what am I going to be doing now? This is the thing that I'd sort of committed to and seen through all sorts of ups and downs. And so, so about a year ago, I then said, okay, this thing's canceled. Let me go look at what else is out there. So I started to find within GM, there was like a little bit of appetite for using Rust, but not like a lot. And so for a few months, 2-3 months or so, within the automated driving sort of / ADAS domain, talking with the sort of chief architect and, lead engineers and those sorts of things to get people familiar with Rust and get them interested in Rust, because I'd been doing C and C++ for like 10 years, and I found Rust in 2017 or so. And I just thought that it was a better way of developing safety critical software. So sort of with Ultra Cruise in the rearview mirror, I was thinking, okay, maybe that's the thing that I can do at GM, is I can sort of try to bring Rust to the forefront and make it possible to use it as a normal language of development within the domain that I was in at the time. But yeah, after a few months of being given sort of an assignment, hey, can Rust do this? And I show, yes, it can do that. Hey, can it do that? Yes, it can do that. I was getting a little bit tired of this process. And I had gotten a job description sent to me by a coworker for, hey, like there's this job description within GM that mentions Rust. You should like apply to it. So I looked into it. And while I did not get that job within GM, it did lead me down the path of starting to talk with the project lead for Eclipse uProtocol, Stephen Hartley. And that sort of kickstarted my path down, okay, how can I develop and support uProtocol, and what can I do with Rust in that space? I was able to start contributing to uProtocol while still working sort of my day job. And this was kind of a good thing. I tend to sort of like want to own things too much or kind of like get invested in things too much. And so when I was getting interested in uProtocol, this was kind of a good thing. It helped me improve my delegation skills as I sort of no longer wanted to be 100% doing what I was doing for my sort of day job at the time, where I was still a localization engineer. This helped me sort of gather a team and, still keep working on what we were working on, because even though Ultra Cruise had been canceled, our manager had found a good means of still using the software that we had developed. So I was working with some members of the team to change out interfaces and do some things like this to get our software able to be used, still in the automated driving domain, just with a different product. So anyway, so while that's going on and I'm learning delegation skills and learning how to be more hands off, then I started, working on Eclipse uProtocol. So it was very small stuff at the beginning, which I think is pretty typical in open source. So for example, I just read all the code of the Rust language library implementation of uProtocol, which by that point I think had merged. I read the whole spec and I really just tried to be curious. I tried to ask questions. So, I'd read something in the spec. I'd think that kind of doesn't make sense to me. What might be going on here? Reach out to the project lead or post an issue on GitHub and say, what's going on here? And this led to me just becoming more involved gradually with the project, making, a small pull request to fix a thing here or there, to where the project lead, I think, so Stephen Hartley, started to get a little bit more comfortable with my contributions. And we talked a bit about me coming and joining a team within GM that was doing this uProtocol stuff full time. And sort of one thing led to the other. And over the next few months, I kept working on uProtocol and was then able to, switch from being an engineer working on localization in the ADAS space, automated driving space, over to being an engineer working on, more like middleware system software for uProtocol, which, was a big change, but I found I really liked this domain. I liked sort of going a little bit lower level. So this is a fun change for me to make.
I don't recall if we actually kind of talked a little bit more about what exactly is uProtocol. We keep mentioning it and working on it, but what is this, uProtocol?
Yeah, no, that's totally fair. Okay, so let me take one big step back. So there's this concept in the automotive sector about software defined vehicle, right? So in sort of the bad old days at an automotive OEM, like a GM or a Ford or pretty much any OEM, the way that things would work is that you would have, as the automaker, some computer that you have in the vehicle that does some stuff, but you would also have a lot of these sort of boxes that you would buy and plug into your vehicle network, which also do stuff, but they would ultimately, be black boxes and be software that was controlled by a supplier and be on its own little computer in the car. And this makes it very difficult to sort of update software and change software and be more flexible in the software that you deploy. It's more or less like in the bad old days, a vehicle was kind of just completely baked and done and rolled off the line, and that was it, unless you brought it to a dealership. And, they may be able to update some things, may not be able to update others. So that's kind of how it was in the bad old days. The way that things are changing these days, influenced by newer OEMs that own more of their own stack, is towards okay, how do we make our deployment easier of software to the vehicle? How can we do over-the-air updates? How can we dynamically shift where software is deployed from, say, one compute in the vehicle to the other? So these are all questions that have been coming up for the last 5-10 years. And there's this Eclipse software-defined vehicle group that was started up as part of the Eclipse Foundation to help kind of give a level playing field for automotive OEMs and for suppliers to be able to come into and develop software in a way that's open, right? So that everybody kind of can know what's going on. And really, frankly, a lot of these organizations, it's to avoid antitrust issues, right? So if it's open to everyone, if it's open for all players to kind of come in and discuss and look at the software and develop software, then this can make it easier access. So the Eclipse uProtocol is a project under the Eclipse SDV. thus the Eclipse in front of its name. So its goal really is to aid in some of those things that I mentioned earlier. So in the old days, you may have typically, if you have software that's on some compute inside the vehicle, you may have used, say, like very vendor specific, maybe operating system specific proprietary communication mechanisms for software that's communicating between one another. That would in turn cause you to have a lot of vendor lock-in. So you would not want to change your compute for, say, the next refresh of this device in the vehicle. Or if, say, you did not want to be locked into that vendor, potentially a lot of tear up of interface software that was there. There were things that happened a while back, things within the AutoSAR Foundation to try to make this a little bit easier. So things like ARXML, where it's like an XML document essentially that describes interfaces and all this kind of stuff. But that is a little bit lacking. There's a lot of, again, vendor lock in there because these AutoSAR Foundation specs and these sorts of things are technically not open source. They are part of this foundation, and you cannot sort of just willy-nilly implement stuff and put it into the open source that is from this AutoSAR Foundation. You actually have to buy stuff from a vendor that is also part of the AutoSAR Foundation. So you end up in the situation of where this thing that was intended to make things like a little bit more open and more, I guess open is not the right word, maybe compatible. So this AutoSAR Foundation thing is supposed to like make software a bit more compatible, but at the end of the day, you sort of still had to go to a vendor and get some proprietary software to make all of these communication things work. So the idea then was behind the Eclipse SDV was like, okay, like let's truly make it open. Let's make this thing available to everybody. So getting back now with some of that background, getting back to your original question of, okay, we've been talking about dancing around uProtocol. What is this thing? So uProtocol is essentially a 3-layered protocol that lets you write your software speaking uProtocol. It's kind of an opinionated communications framework. So it's got things like pub/sub, notifications, RPC. So you've got these sort of typical idioms for like middleware and communications. But the thing that really differentiates it is that because it's this multi-layered protocol, layer one of that is this transport layer. So we've written a lot of software which is generic over this transport layer. Our protocol bridging library, our subscription management stuff, all of those things are able to have different transports swapped into them. They're written in kind of like a plugin like fashion. This helps its adoption. This helps people be able to use it even in cases where, say, they may actually have to use some sort of closed source proprietary library to do communications. They would just write a transport implementation for that, then be able to plug into these other things like this pub/sub, RPC, notifications mechanism. So it will help you write your software. This is like the dream, right? This is what I think, I think what a lot of folks talk about in other spaces, but it's like the write once, run anywhere. I don't know that it's truly that, but it's write the one time and you may be able to shift it around within the vehicle, say from one compute to another, and be able to use that same software between different refreshes of these devices within the vehicle. So if you've written software for an infotainment device for this model here, in 3-4 model years when that refreshes, you can move that software over there as well. So yeah, that's kind of the concept. Be an opinionated communications framework, but with this goal of improving software reuse and reprovisioning within the vehicle, and then also out to the cloud and mobile.
Yeah, if I remember, if I heard correctly, it's transport agnostic, right? So it depends on how your computes or your inter services talk to each other, right?
Yeah, exactly. So the concept being that we have this multi-layered protocol where that first layer, the transport layer, we can swap out what we use. You can write your own, so long as you provide just a send, a register listener, and an unregister listener API for how to do that over that protocol. Then you can plug that into the rest of the ecosystem for uProtocol. So currently in our reference implementation, for example, we have Zeno, we have SumIP, and we've got MQTT5 as our transports that are included in this reference MVP topology. However, so long as these three APIs of send, register listener, and unregister listener are implemented, you could use whatever transport that you wanted with these components that I mentioned, like the protocol bridging library called uStreamer, and with the subscription management library, uSubscription. You'll find that everything is prepended with U. So it's just sort of the hazard of using uProtocol.
Okay, yeah, because that was actually going to be my next question is like, how many different protocols and how do these things actually talk to each other? So I was just looking at the Zeno or Zeno. Is it like a zero MQ kind of thing? It's kind of like really a low kind of resource kind of service or protocol that things can kind of do a pub sub kind of mechanism or
Yeah. So Zeno, yeah, is the choice that we made for most of the communications sort of on device in a reference vehicle topology. That's because it is fairly flexible, I think, as you're pointing out. And it's like low latency, low sort of memory footprint, very efficient. Zeno just hit its 1.0 last week, actually. So, happy birthday to them. So I've worked with them a bit on protocol. The great thing about Zeno and why we chose to use it in this reference topology is that it can have different protocols, in fact, backing it as well. So if you need to ensure that you have a message that truly does get from point A to point B, you can have it be backed by TCP. But if you, say, are doing some sort of like ADAS kind of application where you have camera images that you're running neural nets on and maybe needing to do different things with, and you want to ensure you don't make a bunch of copies of these big blobs of memory, you can do that using Zeno as well because they have a shared memory backing, which you can use for those kinds of applications. So that's why we used it for, in this reference topology, sort of the within device communications and many of the communications between devices. It's really for cases where you need to get off the vehicle, where we had MQTT5 as that transport. I'm not really up on the space and up on cloud technologies, but from what I have been told, MQTT5 is like a fairly common choice and like well supported by cloud infra sort of providers as being a way to communicate back and forth. So that was the choice that was made there. And then the other protocol, the reason for that choice for some IP is that within the automotive domain, there's a few technologies that have been around over the years. There's CAN, there's FlexRay, there's Ethernet. And these are here, they're coming along. I think Ethernet is starting to make more inroads. And so that's what we chose for this third protocol is some IP. So this is a protocol that is part of the AUTOSAR Foundation. So I was mentioning that earlier, but there's a first implementation of some IP called vSum IP that actually was put out into open source before this was accepted into the AUTOSAR Foundation. So it like technically was able to get around this issue by being made public before it was accepted by the AUTOSAR Foundation. So the reason for using this protocol is that there's still a fair amount of communications that happen within the vehicle to mechatronics devices. So these are things like your brake controller or say like an IMU that's used for, determining if you've been in a collision to activate your airbag, right? So some IP is still used fairly often in those kinds of mechatronics devices, which are lower power and devoted to, say, like some specific task within the vehicle, usually some sort of sensor or some sort of actuator. And a lot of that software is already sort of safety qualified and hardened. And we didn't want to essentially have to rewrite any of that software or touch any of that software. So it was important that we have this some IP transport be available to be able to still communicate to these more safety critical mechatronics devices.
so I just want to kind of understand a little bit more because you have all these different microservices that are running in this car, right? And it sounds like these things are all networked, right? Because when I think about a computer, like obviously I need internet because I'm usually reaching out to outside services. I don't think a lot of services are using, IPs and ports and all this kind of stuff, but maybe I am wrong in that case because like I was thinking, okay, COM ports or, USB files or something like that, like are they using more of like a socket based thing? But it sounds like that's not true. So it actually is using like each service has its own like internal IP and they're broadcasting like basically an event based architecture. and then each of these services just listening on certain topics and then reacting upon those different data. Is that actually how cars work?
The answer is like all things in life is it depends. But for many years, I think that there's been this goal with SDV to move towards this what's called a service oriented architecture. We're less thinking about some sort of specific identifier of like this particular device, right? That's again part of the reason that we chose to use some IP and chose to use Zeno is that these kinds of details are hidden away from us. We don't need to consider those things. So for Zeno, for example, you don't need to specify which device you're trying to communicate to. It works like I think many middleware do, where you instead specify some sort of key. So you specify, hey, I want to talk to, say, like my VIN number, right? Vehicle identification number, I think it stands for my VIN number slash body slash window slash like go up or something, right? So you want to be able to talk to that specific topic or call a function on that specific topic. You don't want to have to specify a certain IP address and a certain port and yada yada to be able to communicate. Because that, again, you made a good point here, is that having these sorts of protocols where we don't need to specify these things can aid us in having reusable software, whether that software is moved around within the vehicle or it's to another model year or to another model entirely that may have a lower power compute. This is one of the things that's important and why we also have this uDiscovery service. Again, everything comes with U in front, but a discovery service that we have as a part of uProtocol where if you have some information about the service that you're trying to access, but you don't have everything, you can query it. So you can say, hey, like, I'm not sure about everything about the service. I think it's called this, or here's like a wild-carded identifier for what this thing is called. And you can get back information enough about it that you'll then be able to query and make service calls to it.
That sounds really useful because basically you can, I mean, theoretically, I don't know how realistic this is, but theoretically start swapping out parts as long as they speak this U protocol and they're expecting the messages. As long as you got that, then that, is fine. It's just like, I guess that glue layer between the two is really what really matters, right?
Exactly. So the idea there being that, if you have two pieces of software, two apps communicating with one another on a single device, and they're both using uProtocol to talk to one another, and they're backed by Zeno, right? That's the layer one transport that they're backed by, and they're both communicating to one another. That's great. If you say need to move this piece of software from maybe this domain, maybe this is on some ADAS compute. If you need to move this software from this domain, you need to move it over to, say, the infotainment domain. Then when you move it over there, you can still have these two pieces of software be communicating. I'd say probably the worst case scenario would be you need to change out what the transport is that you're using underneath, right? So if, say, on device A, it's Zeno that's being used to back all these communications, and over here on device B, it's MQTT, you would just swap out, okay, instead of using Zeno as my backing transport for this app, I'm going to use MQTT, and they'll still be able to communicate. As to why it works, it's due to this component that I developed working as part of uProtocol called the uStreamer. So this is a protocol bridging library. So this lets you say, if you are communicating between these two devices and, say, device A speaks sort of Zeno internally to it, device B sort of speaks MQTT internally to it. To be able to bridge those communications, there's this app, essentially the system service that's running on each that knows how to speak both protocols and can make those translations. So if on device A, you've got an app that's saying like, hey, tell me how many taps there have been on the screen of the infotainment in the last 10 seconds. That's sent out as a message that's backed by Zeno. It's picked up by this uStreamer. The uStreamer can then convert that message over to be an MQTT backed message, send it out over the network within the vehicle. And then over here, the same process can happen in reverse, where this message, which is backed by MQTT, can be received by the uStreamer, swapped over to be backed by, it's sent out over Zeno, I guess in this case, can be swapped over to be backed by MQTT and then be received by this app that we've moved from one device to another. So yeah, that's one of the big benefits of it is that, yeah, you can move software around within the vehicle with, very little changes that would be required.
I'm also kind of curious, how often does software move from one component to another? Because that sounds kind of weird, right? Because everybody's just used to one computer and maybe you move your software by, changing folders on your drive. But I mean, like, how often really, like, are you going like from one, say, I don't know, I don't even know where to even talk about because you talked about a compute, right? I mean, so can you talk a little bit more about where things could possibly move from?
It's like a perennial problem. It's like a forever problem in the automotive domain that where, okay, new model year vehicles coming out, it's being refreshed. We have some new compute. We have basically some device in the vehicle that will be running maybe QNX, maybe some sort of real-time Linux, something like this. And we're going to be putting applications on it. Applications which need to interact with sensors on the vehicle, do actuation, that need to interact with the some of the infotainment stuff. So there's these various computers essentially that are on this vehicle, and I think your description earlier was very accurate, which is it's like a bunch of microservices. It's a bunch of smaller applications that are talking to one another. It's extremely common when this new compute is coming online. Everyone is rushing through the door to try to get on the new compute. It's like, okay, we need to get this app there, we need to get that app there, yada yada yada, to the point where it's very, very typical by the time a vehicle would be launching, the compute is entirely full or 110% full or 120% full. And there have to be other strategies that are brought to bear on, like, okay, we're going to sleep these apps, or we're going to only start these apps at these certain times. And this makes it very tricky to update these vehicles in the future. However, it's very possible, and I've seen this as well, that you may have one compute within a vehicle that is sort of 120% full, but then you have another one that's like 20% full because there just may not have been the right trade-offs made in where to put the budget behind the compute within the vehicle, right? So in that case, you have 80% of this compute over here that's just sitting there unused. How can we make use of that? What are the apps that we can choose to, say, shift from this overloaded one to this one that's a little bit more empty, a little more able to run more applications? And so in a sort of typical old way of doing things, all this stuff is just sort of baked by the time the vehicle rolls off the line, and you really have no chance to shift these things around or update software very effectively. But with this concept of a software-defined vehicle and sort of what uProtocol enables, then you can have these kinds of changes in distribution of software workloads over the vehicle's lifetime. So whereas, in the past, okay, it ships, it bakes, just is what it is. Now, if it ships and say that first compute would have been, say, 120% full, before it ships, we may be able to spend a few months and move certain apps, make certain trade-offs to unburden other compute and make there be room for updates for software in the future, and do that with over-the-air updates as well to be able to shift software around. So this is one of the things that I've seen a few times, I guess I would say, is, yeah, everyone rushing in trying to get onto the new compute.
We've been talking a lot about this stuff. It's very interesting, very complicated, and there's a lot to say about it. But this is a Rust podcast, and I feel like we've forgotten kind of like, okay, there's Rust somewhere in there somewhere.
Yeah.
But I'd like to spend quite a bit of the remaining time to talk about, hey, where does Rust fit in all this stuff? We talked before the show, you got Python client, you got a Java client, you have, I think it's originally C++ or C kind of client stuff. And then, yeah, you added in Rust, right? So where does Rust fit in? Is it actually backing some other libraries or other languages? And has this brought any positives or even negatives to
The way that we tried to bring Rust in here is we tried to make it possible to write these apps in Rust as first class citizens, right? So it is definitely possible to, say, write what we call U entities in Rust that can do whatever you want. They can communicate over all these protocols that I've mentioned. However, the reality of the automotive domain is that many folks are not yet quite comfortable with Rust, if not maybe used Rust very much. And so the choice that we made was to allow Rust apps to be, yeah, first-class citizens. They can be written, they can communicate with C++ apps, Python apps, Java apps, all that stuff. That's all there. But The choice we made was to focus on using Rust for these sort of critical infrastructural type of services that must be more reliable and robust. So, the couple of things I've been mentioning during our chat so far, the protocol bridging library, this uStreamer, this is written in Rust, and also the subscription manager library, this is also written in Rust. So, these are the two components that we thought would be a great place to use Rust because ultimately an automotive engineer that may not be as familiar with it would not have to sort of jump in and start writing Rust to configure these things. These would be more like changing some configuration files, right, to switch around some of the behaviors rather than needing to sort of get in and start doing a lot of Rust software development. So yeah, it's kind of like a Pareto principle style of decision making here that we'll use Rust in sort of these key places that may end up being maybe only like 5 to 10% of the sort of overall software written maybe for a particular vehicle, maybe even like 1% if you've got like all these apps that are written for it, but they're very critical roles, I guess.
I kind of like to ask you, since you're in the automotive industry, we have something called Ferrocene, which I'm sure you've heard of before. And I think there's also other comparable stuff, or if not, there's definitely going to be. Do you feel that Rust is actually, going to be more and more accepted and definitely something that people should be looking at and even using in the automotive industry?
Yeah, yeah. I think it's coming. You mentioned Ferrocene. This is, I attended the Ferrocene sort of launch party last year. I think it was in November where they announced, hey, like we are safety qualified. We're ISO 26262 safety qualified. You can now use this for automotive. And there's just, C and C++, they have brought us a long way. And I have a lot of appreciation for what we've been able to do. It's just that there are classes of issues which are not possible within Rust, which if folks are listening to this, they're probably well aware of, but things like memory safety, thread safety, there's all sorts of developer ergonomics improvements as well that I think that, yeah, Rust is on its way. When I was at RustConf in Montreal, I had a chance to attend the Rust Safety Critical Consortium that's being kicked off by the Rust Foundation. And there was a lot of good talk around it. Ampere mentioned that automotive manufacturer. So they mentioned that, yeah, they are heavily invested and they sent someone to give a talk about their usage of Rust in automotive, as well as Volvo Cars is also, they've put it into a non-safety critical compute. They've been able to ship that. That's in production. So I really think that this is going to sort of have a snowball effect as more folks start to use Rust within automotive and as more folks start to go out and talk about their experiences using Rust and give kind of that social proof that Rust is a good choice for writing safety critical software. So I think it's coming. I think it's on its way. We'll see where we are in maybe 5 years or so. I hope to see a bit more Rust.
Well, it's good to hear. I don't want to take you because I know you have something to do very soon. I guess I'll just leave, last word for you if you have anything you want to plug or anything you want to say before we sign off.
Yeah, sure. So one thing that I wanted to sort of circle back to was that oftentimes in industry, there's like this dilemma, right? Do we use the new technology? Do we not? And what I found that was good about Rust is that because there is a lot of interoperability with C and C++ with this uStreamer library that I wrote, I was able to interoperate with C++. I was able to interoperate with this C++ library, which does some IP communications. And there's a trade-off to be made there, right? Like in an ideal world, sure, like maybe everything can be written in Rust, but in this case, it felt much more appropriate that, okay, like maybe I can't have 100% of this streamer code base be written in Rust. Maybe it's like 90% Rust and 10% C++. And that's just sort of the way that it has to be until we proceed, a little bit further down the line. But yeah, stuff about me. So yeah, I'm Pete LeVasseur. Probably heard my name here at the top of the podcast too, but I'm a maintainer, as was mentioned, for Eclipse uProtocol. We have an alpha release coming out at the end of November, and given the restructuring that happened at GM in August or so, the amount of contributors that we had is decreased. So we'd love to have your participation. We have a Slack channel. If you just search for Eclipse SDV, get engaged, you can find it. And yeah, I am running a Rust consultancy called Oxidation Partners. So whether you're interested in particularly Eclipse uProtocol or just how you can use Rust to improve maybe the safety or the quality of your software, yeah, I'd be happy if you took a look at my blog, saw it was on offer, and reached out.
Well, Pete, it's good to have you on, and hopefully we'll have you back on in the future. It'd be interesting to have like a automotive, like Rust podcast kind of panel thing. It'd be, I don't know if we have enough people in the industry to talk about that, but it would be really interesting to hear.
Yeah, that'd be great. I think we do. I know a few people, so it'd be a fun time.
All right, sounds good. Again, thanks for coming on, and hopefully we'll have you back on in the future. Maybe it's for that Rust Automotive Consortium.
Sounds great.